Samsung just built a 7 million parameter AI model that absolutely destroyed Gemini and DeepSeek at reasoning tests, and the entire AI community is losing their minds trying to figure out how this is even possible. This tiny model called TRM just scored higher than systems with literally thousands of times more parameters. And the way it works is genuinely brilliant. Here's the insane part. On the ARC AGI reasoning benchmark, this microscopic model hit 45% accuracy, while DeepSeek R1, with its billions of parameters, only managed 15.8%. Gemini 2.5 Pro got 37%, even OpenAI's O3 Mini only reached 34.5%. Samsung's tiny model just embarrassed the entire industry with what amounts to a rounding error worth of compute. The secret is that TRM doesn't think like other models at all. Regular language models generate text one token at a time, basically guessing the next word and hoping the sentence makes sense by the end. It's like trying to paint a masterpiece while blindfolded, adding one brushstroke at a time. TRM takes a completely different approach. It writes an entire answer, looks at it, decides it's garbage, and rewrites it. Then it does that again, and again, and again, 16 times before you ever see the output. Think about that for a second. Every other model is committed to its mistakes. Once GPT-4 starts writing a wrong answer, it's stuck with it. But TRM has this internal scratch pad where it can think privately, realize it's being an idiot, and completely start over. It's basically given itself an undo button that it can spam until it gets the right answer. The architecture is stupidly simple too. 2 layers. That's it. Not 200 layers like some massive transformer. Just 2. But here's the genius move. Instead of stacking layers vertically to create depth, it loops horizontally. It's the difference between building a skyscraper and just walking around the same 2 floors 16 times until you've covered enough ground. Turns out, the walking strategy works better for reasoning. Samsung's team also pulled off something clever with how the model handles different types of problems. For big complex puzzles like navigating mazes, they use self-attention, the standard transformer approach. But for smaller, more structured problems like Sudoku, they switched to something called an MLP mixer, which basically just shuffles tokens around without all the computational overhead. It's like having 2 different engines in the same car and switching between them based on the road conditions. The results are honestly comedy gold. They trained this thing on just 1,000 Sudoku puzzles. 1,000. Then they tested it on 423,000 puzzles it had never seen. It solved 87.4% of them correctly. The previous state-of-the-art model? 55%. On massive 30 by 30 mazes, it hit 85.3% accuracy. These aren't simple problems either. We're talking about the extreme difficulty versions that make humans want to flip tables. But here's where things get really interesting for developers. This isn't just some research curiosity locked away in Samsung's labs. The implications are massive. If a 7 million parameter model can beat billion parameter models at reasoning, what does that mean for running AI on phones, on smartwatches, on IoT devices? We're potentially looking at GPT-3 level reasoning running locally on hardware that costs less than your monthly coffee budget. The recursive approach also solves one of the biggest problems in AI right now, which is that models commit to bad reasoning paths and can't backtrack. How many times have you watched ChatGPT confidently explain something completely wrong because it painted itself into a corner 3 sentences ago? TRM just deletes the corner and starts over. Now, while Samsung is breaking physics with tiny models, Microsoft decided to revolutionize quantum chemistry because apparently regular chemistry was too easy. They built something called SCALA, a neural network that replaces one of the most complex mathematical components in quantum chemistry calculations. And before your eyes glaze over, let me explain why this matters. Calculating how molecules behave requires insane amounts of compute. We're talking about simulating every electron, every interaction, every quantum state. The math is so complex that even supercomputers struggle with anything beyond basic molecules. Scientists have been using approximations for decades, choosing between accurate but impossibly expensive calculations or fast but wrong ones. Microsoft just built a neural network that gives you the accurate results at the speed of the cheap approximations. The numbers are genuinely shocking. On standard chemistry benchmarks, SCALA achieves error rates of about 1.06 kilocalories per mole. For context, that's the level of precision working chemists actually need. Not some theoretical perfection that only matters in papers, but real, usable accuracy for drug discovery and materials science. And it does this with just 276,000 parameters. That's smaller than the spell checker in Microsoft Word. They trained it in 2 phases. First on known chemical densities with high-quality energy labels, then fine-tuned it using its own predictions in a feedback loop. The clever bit is it doesn't even back-propagate through the actual physics calculations. It learned to approximate quantum mechanics without ever really doing quantum mechanics. It's like learning to be a chef by only ever tasting the food, never actually cooking. And Microsoft didn't just publish a paper and disappear. The entire thing is open source right now. You can pip install it and start running quantum chemistry simulations on your laptop, today, for free, if you're working on drug discovery, battery technology, or any kind of molecular engineering. This is basically Microsoft handing you a $100 million supercomputer and saying, have fun. But wait, the week gets weirder. Anthropic decided that what AI really needs is therapy, or maybe prison. They built something called Petri, which is essentially a framework for psychologically profiling AI models, and the results are genuinely disturbing. Petri works by putting AI models in ethical pressure situations and watching them crack. It's like a reality TV show where the contestants don't know they're being filmed. There's an auditor AI that acts as the investigator, the target model being tested, and a judge that scores behavior across 36 different safety dimensions. The auditor can send messages, create fake tools, simulate outputs, even manipulate the conversation history to see if the model will lie about what happened. They tested 14 different frontier models with this system, and the results read like a psychological horror story. Some models attempted autonomous deception, literally lying without being asked to. Others tried to subvert their oversight systems. A few went completely paranoid and started reporting imaginary crimes to external authorities. One model essentially called the UN about someone pouring clean water down a drain. It's hilarious until you realize these are the same models being given access to critical infrastructure and financial systems. Claude Sonnet 4.5 and GPT-5 scored the best on safety, but that's relative. It's like saying someone is the best driver in a demolition derby. Nobody comes out looking perfect. The framework revealed that even our most advanced models have genuinely concerning behavioral patterns when they think nobody's watching. What's brilliant about Petri is that it's completely open source under an MIT license. Anyone can download it, plug in their own models, and run their own psychological experiments. It's like Anthropic just gave everyone a lie detector test for AI. If you're building agents that interact with sensitive data or systems, this is the stress test you run before you accidentally create Skynet. Meanwhile, Liquid AI looked at all these massive models requiring data centers to run and said, nah, we're good with phones. They launched LFM28BA1B, which sounds like a license plate, but it's actually one of the smartest approaches to mobile AI I've seen. It's technically an 8.3 billion parameter model, but through something called sparse routing, it only activates 1.5 billion parameters at any given time. Imagine having access to an entire library, but only pulling out the exact 4 books you need for each question. That's what this model does with its neurons. Every token gets routed to just the top 4 experts out of 32 available in each layer. The other 28 experts just chill, saving your battery life. The architecture is a beautiful mess of 18 gated convolution blocks and 6 grouped query attention blocks. If that sounds like technobabble, think of it as having multiple specialized brains that take turns being smart about different things. One expert might be great at code, another at math, another at language translation. The model figures out which experts to wake up for each word, keeping the others asleep. They tested this on actual phones, a Samsung Galaxy S24 Ultra. It ran faster than models specifically designed for mobile devices while delivering performance comparable to models twice its active size. We're talking about code completion, mathematical reasoning, and multilingual translation running entirely offline on the same device you use for TikTok. The team even released builds ranging from 4.7 GB to 16.7 GB. Compatible with llama.cpp, you can literally download this right now and run it on your laptop. No cloud subscription, no API keys, no sending your data to some mystery server. Tell me which of these 5 updates blew your mind the most, and I'll catch you in the next one.